folks. Okay, well, this time I want to talk a little bit about input and output streams in Linux. So we've been doing a lot of work so far where we're using things like cin or scanf to read the text that the user is typing in as they're running a program. And we've been using cout to write information to, say, the monitor, the terminal, as the program runs to display things for the user. But we haven't really talked too much about what's going on kind of behind the scenes. So in fact, whenever Linux is taking input and feeding it into a program, it's reading from what we refer to as a stream or sometimes as a buffer. It's basically just reading data from some source and directing that to the program that's running. Similarly, when a program is producing output, Linux is just taking whatever that program is writing out and sending that to some destination. So by default, the source that we're using for input is the keyboard. The destination that we're using for output is the monitor. But that can be redirected elsewhere. We can decide to, say, run this program, and when it asks for input, we'll actually take that from a file unknown to the program instead of taking it from the keyboard. Or similarly, when a program is producing output, we can take whatever it's producing and actually redirect that to a file someplace if we want. So these two kind of streams of where stuff is coming from and where stuff is going to are referred to as standard input for where we're getting our input from and standard output for where we're sending our typical output to. So if you hear people talking about standard input, standard output, they're just talking about, where are we getting the data for the program? Where are we sending the output from the program? There is actually a second output stream that we haven't really talked about called stderr. And it allows us essentially to have a program sending output to two different destinations. One of them for, if you like, normal output, and one of them for error messages. And this is quite often used by programs as a way to allow the user to keep track of regular information separately from error messages. So if, for instance, a program's producing a bunch of data output, but it can also produce error messages, maybe we want to store the data output someplace no matter what, but not have that polluted with the error messages. So we might want the program to send them to two different locations, two different streams. And so this second stream is often called stderr. And the abbreviations you'll see for them are stdin for standard input, stdout for standard output, and stderr for standard error. And again, we'll have a little bit of a play with redirecting this from the command line in a moment, but that's the basic idea, so that a program can send output to different destinations. Now, by default, both of these things are dumped to the screen. So if you just run a program normally, it sends all of the program's standard output to the screen, it sends all of the program's standard error messages to the screen, and the user sees everything that the program's trying to tell them. But we can split that, if you like, to send them to two different locations. Send one of them to a file, or send one of them to one file and another to another file, or whatever mix we want, send both of them to a file someplace. And so we've got this idea that scripts and programs and Linux users that are running other programs can take the output that that program is generating and decide which things get redirected where. And that's the idea. It just gives the user a little bit more control over what to do with the output that a program produces. So we want to know within our C++ programs, how can we make use of stderr, and how can we split things between these two different streams? So cout is the one that we've been using for the most part, where we've got some text that we want to display. The other one, to send things to the stderr, is just called cerr instead of cout. Right? So just whether we're sending to the output stream or the error stream. So other than that, it's syntactically identical. So anything you do with cout, you can do with cerr. They both come from IO stream, so you don't have to include any special libraries or go through any special hoops to do this. You just actually say cerr instead of cout. So again, by default, both of these things get sent to the terminal window. Just as far as the user is concerned, under normal circumstances, these don't look any different in terms of output. But if they want to, they can pick which ones go where. So again, this is typically used for error handling, where we'll send our normal output to the output stream and any error messages, maybe warning messages, to the error stream. So let's say we ask the user to enter an integer. We read in what they typed, and if something goes wrong, if they didn't enter an integer, or maybe if they entered a negative number, we'll give them an error message. So our regular prompt goes to our standard output, cout. But if something goes wrong, that error message that wasn't an integer will send to cerr. Or again, maybe if the quantity was too small, we'll give them a different error message for that and send it to cerr. But this is generally the idea. Error messages, warnings go to cerr, everything else goes to cout. Then when we're running the program from the command line, we can pick which output goes where. So if I just run, /my program, everything goes to the screen. It all appears kind of in the order it was printed out. I can use this greater than symbol to say, okay, the normal output, the cout stuff, send it to a file. So if I do this, if I run my program and say my program, greater than, and then some file name, it's going to take all of the cout stuff and dump it into the file. The cerr stuff is still going to appear on the screen, so you get this separation, right? The data goes into some file and the error messages go to the screen. We can actually use a similar form of redirection to read input from a file. So I can run my program and say, when you're doing cins, take it from this file instead of from what the user is typing. So as far as the program has no idea that you're doing this, right? This is something we're doing at the Linux end of things, and we're just saying, well, when the program is running, when it thinks it's reading, just take that input from the file. And you can combine the two if you like. So we can run the program, say, take the input from this file and send the standard output to this other file. So we can do redirection of just the regular output if we want to. We can also redirect just the cerr if we want and not the cout. So this one is saying run the program, send the error messages to this other file. So this 2 greater than is what redirects the standard error. So I can say send the error messages to this other file, but leave the regular couts going to the screen. So we can pick and choose when we run the program what goes where. Or we can decide if we want to redirect both the standard input, or standard output, and the standard error to the same location. It's the and greater than. So we've got these 3 possibilities. Just the greater than sends the output. The 2 greater than sends the error. The and greater than sends both. So you can pick and choose what you want to redirect. And actually, just as an aside, if you want to kind of chain programs together, take the output from one program and send it as the input to another, you can use the vertical bar, this pipe symbol. So this would run this first program, and whatever output it produces, whatever cout it produces, goes into the second program as that second program's input. So you can start chaining things together if you like. But this notion of cout and cerr just allows us in the program to say, okay, here's the stuff I want to go to standard output, here's the stuff I want to go to standard error, and then the Linux user can pick what they want to do with those things once it's there. So that is the idea. Maybe we'll have just a quick little play with this to kind of reinforce some of the ideas. So here we've got a program that just does a little bit of intermixed. So we've got a couple of a cout, a cerr, a cout. Oops, let's make that a cerr. So we'll print a message going to standard output, and then one going to standard error, and then more to standard output, and more to standard error. And again, the only thing that's different is whether we're saying it goes to cout or cerr. Right? We still just need our regular old IO stream library to do this. We'll compile the beastie. And if we just run it normally, all of that stuff goes to the screen, right? Stuff going to standard output, standard error, standard out, standard error, and it just appears in whatever order it was displayed. If I decide that I want to redirect the standard output, I don't know, standard out here. So we'll just come up with some file name, and the standard output has now gone into that file, whereas the standard error still shows up on the screen. And again, if we have a look at what's in that standard out, you'll see that the standard output did indeed go there. Or if we try the same sort of idea, where let's try that to greater than, and we'll have another file where we say, okay, we'll put the standard error here, and the standard output is still going to come to the screen. Right, so we get the standard output on the screen, and we see that the standard error wound up in that other file. And again, if you want to try the same sort of idea where we'll redirect everything, everything goes to that file. So from the command line, you can pick and choose where standard input goes and where standard error goes. So that is really the idea. There's nothing too terribly complex about it, but I did want to make sure that folks had an idea of both how you create the different output streams in your C++ program and how you can use them from the command line. All right, we will leave that one there.